So, good evening. And this class, we are going to discuss the operation of PNP transistor. The last class, we have discussed the operation of NPN transistor. This operation of PNP transistor and NPN transistor are both are similar. Only thing is, in the PNP transistor, in P type, the majority plates for electron hole recombination. Okay. So first we are discussing the working principle, means we have to discuss the one which we are not going to provide any external supply. We are not providing an external supply just like this. At this junction, a depletion layer is formed, and at this junction, a depletion layer is formed because of the effect, because this Pn represents the P-N junction diode, this NPN represents another one P-N junction diode, which are connected back to back. So a depletion region gets formed. Okay, so similar to that, the depletion region in the collector junction, that is this junction, will be larger compared to the depletion region in this junction. So you can see this diagram here, the collector base junction, and in the emitter base junction, it is very thinner compared to the collector base junction. So in the PNP transistor, in P type, the holes are the majority carriers, electrons, a few number of electrons present in the base region. Why this P region where this will be having a few electrons? Because base region is thin and lightly doped. So very few electrons are available for recombination. Now we are going to provide an external voltage. When we are providing an external voltage, as you know, the collector base junction should be reverse biased and the emitter base junction should be forward biased. The positive terminal will be connected to the base for the forward bias condition. And now the positive terminal is connected to the base, that is N type, and the negative terminal is connected to the collector terminal P type for the reverse bias condition. So as per that, you can see P should be connected to P and P2 negative for the reverse bias condition. Now, once the potential is applied during the forward bias condition, the electrons which constitute the emitter current, a few holes, will be towards the base region, and these electrons, few electrons only, can able to recombine with the holes, as the holes are present will be having a fewer number. And because of this, a small current, IB current, that is the base current, is constituted collector junction. And that means the previous case, as we have discussed, 5 only going to 98 will be collected in the collector. So the remaining will be collected in the collector. Okay, so the base current is IB and the collector current is IC. IB is again very controls the emitter to collector. Now we are going to give a more reverse bias voltage, means that is for reverse bias more than 0.7 voltage, means the current cannot flow through the device. We are, in order to overcome that, we have to use some resistors, which are the limiting resistors, to limit the maximum amount of current through this. So while connecting as a circuit, and this is the output, so it is considered to be the load. Okay, we are connecting two resistors, RL and RB, the limiting resistors, to limit the maximum amount of current flow. As we have discussed, the emitter current will be connected as sum of base and C, and your output current IC will be nothing but IE minus IB. That is depending on your Kirchhoff's current law. So that is your operation. So the operation will be similar to your NPN transistor. Only difference in the case is the holes present the majority carriers in P side. So that will be going to recombine with the electrons in the base. Remaining all will be the same. It's very simple. Okay. Thank you, students.